Question number 9. 3 lines are drawn from a single corner of an FCC unit cell to meet the other corner such that they are found to pass exactly through one octahedral void only, no voids of any type, and exactly 2 tetrahedral voids with exactly 1 octahedral void only. Identify the line in the same order. Now, let's first consider the entire cube. Let's consider this as a cube, right? So in this particular cube, first we need to understand the positions of the octahedral voids and the tetrahedral voids. So thus, when we have an FCC, so in an FCC, first point that we need to understand is that the presence of the octahedral voids. So the octahedral voids are present at 2 positions. Mainly, first one, it is present or it is located along the edge center. Secondly, it is located on the body diagonal, on the body center. Okay, so body center. Thus, we can say that it is present along the edges, body center, right? Now, when we observe about the next one, that is for tetrahedral voids. So in the tetrahedral voids, what we observe is the presence of these particular voids on the body diagonal. So it is present along the body diagonal. So therefore, if we consider this particular point to be as a body diagonal over here, the tetrahedral voids are present at a distance of 1/4 from the corners. Okay, so we have the tetrahedral voids, we have the octahedral voids. Now let's consider about the line segments. So when we are speaking about the lines, let's consider the first line, and that is the line which passes through only one octahedral void only. That means it is a line which is passing from one corner to the next corner. Okay, so it should be like, let's consider that this is one corner and this is the next corner. So if the line is passing through this point like this, so naturally it comes across the octahedral void, and the octahedral void, as it is present along the edge center, that means at the center of this particular edge there is a presence of a octahedral void. So therefore our first point, as it passes through one octahedral void, thus it should be the edge diagonal, or you can say as just as edge line. Okay, it should be an edge line. Let's consider the point number 2. Now point number 2 says that it passes one of the lines, passes exactly and in such a way that there are no voids of any type. Okay, so now in the second consideration, it should be as, if we are going to consider this one phase, that means if this particular point represents, if this is a corner and it is going to the next corner in such a way that it is going to pass through the face Along the face, we do not have any type of voids. So therefore, our second point would be as a line passes through no voids. In such cases, thus it should be the face diagonal, right? Let's see the condition number 3. So according to the condition number 3, 2 tetrahedral voids with 1 octahedral voids. Now, we know that the tetrahedral voids are present near the corners and octahedral voids are present in the center of the body. So if I consider this is a position, of our octahedral void. Okay, so let's take this. This is a position of octahedral, right? Now, secondly, what we know is the presence of, at this particular position at 1/4 and 1/4 positions, we have the presence of the tetrahedral voids. So these are going to be the tetrahedral, right? So therefore, as a line passes through 2 tetrahedral voids and 1 in the center, which we have as an octahedral void. So therefore, the last one should be a body diagonal. As the line passes through 2 tetrahedral and 1 octahedral, right? So therefore it should be a body diagonal. So our relationship would be as edge line, then comes is a face diagonal, then comes is a body diagonal. So therefore edge, face, body. Option A is the correct answer.